Okay, so in this lesson, we're going to talk about relations and which relations are functions, okay? So when I talk about relations and functions, it's kind of like apples and like Granny Smith apples. Like all Granny Smith apples are apples, but there's a bunch of other types like Golden Delicious and Red Delicious and Macintosh, a whole bunch. It's kind of like relations are like the apples and the functions are like the Granny Smith. So you want to think of functions like a subset of relations. Like relations are the bigger set. And the cool thing about relations is there's no special rules. But there's a special rule for functions. And basically all you need to worry about is all the x's are called the domain and all the y's are called the range. So back up here where it says there's no special rules, all it does is it just pairs domain or x's with range values, which the range values are the y's, like we talked about here. Now, there's 4 ways to represent relations: ordered pairs, tables, mapping, and graph. Basically, the ordered pairs you can go ahead and graph on the x and y coordinate. The table, you're just going to list each point with the x and then the y on each row so that all the x's are just in the x column and the y's in the y column. And then mapping, we're going to do the first bubble is going to be just the domain, which is your x's, and the second bubble is just the range. And instead of putting your points together like with parentheses and a comma or in a table where you can tell the x goes with the y straight across in the rows, you're going to draw arrows matching which x is paired with which y, okay? So for example, in the domain, remember we talked about for absolute value equations, these curly brackets means the set containing. So this is the set containing the points -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. So if we're going to list the domain, we're going to do the set of just the x's. Okay, so in this case it would be -3, -2, 1, 3, and then we don't have to list -3 twice. So then we're just going to close the set because we already have -3, even though it shows up twice for the x's. And then we do the same thing for the range. We do the set containing all the y's. And so we'll do 1, 0, 2, -4, and 5. You can put them in order from least to greatest. We'll just put them in order as we see them to save time at this point. Now with the table, we're just going to list each point. So -3, 1, for this first point, the -3 is the x and the 1 is the y. And then we just keep going for each point. So we have -2, 0, we have 1, 2, 3, -4, and then we have the last point is -3, 5, okay? Now the domain and range, I like to use the sets because like I said, with the domain, the -3 was listed twice. We don't want to list it twice in our mapping, but we do have to list it as many times as it shows up in the table because the table absolutely connects the x to the y as a point for each row. So like for the domain, I'm just going to list all the x's, but we don't repeat any of the x's. So we have -3, -2, 1, and 3. And then I'm going to list the ranges. So we have 1, 0, 2, -4, and 5. And then I'm going to go, you can either use the table or each of your points. And I'm going to draw an arrow. So the x, -3, goes to the y, that's 1. So I draw from the x, that's -3, an arrow to the 1 in the range. And then 2 goes to 0. 1 goes to 2. 3 goes to -4, and then -3 also goes to 5. So this double arrow shows that there's 2 -3s in the domain. Okay, and then obviously graphing, we can just graph each point. You can either use the table or the ordered pairs. So we start with -3, 1, then -2, 0, and 1, 2, and 3, -4, and then -3, 5. I'm sorry, I went the wrong direction. I even said it right, but I graphed it wrong. So -3, +5. All right, real quick, did I get these? Okay, so that's the only -y. Yep. So go ahead, well, I feel like you guys can do these two on your own. So pause the video and just check to see if you can rewrite the set that they give you as just the domain or just the x's and just the range, the table, the mapping, and the graph. Now if you notice this third one, they actually give you the points, so you kind of have to work backwards a little bit where you're going to read these coordinates and create your set of points for the original relation and then do the rest. So just go ahead and pause the video. Okay, so here you can see we have our domain and range listed and the points, and we connected our domain with each of the range in our mapping, and then plot your points. So check that. And all we did was go and I listed all the points kind of from left to right. So I have my point -5, -4, -2, 3, 0, -3, 2, -5, and 4, 2. So just make sure that you counted the boxes correctly, and then go ahead and check that. Pause it if you need a little more time, but let's look at the functions. And what we talked about with relations is there was no special rule. And relations are like all apples, and functions are like the Granny Smith, where not all apples are Granny Smith, but all Granny Smith are apples. So you want to think as functions as kind of the smaller set. Oops. Okay, and there's a special rule. So basically, what is a function? It's a relation, so it's a set of ordered pairs where each x, which is in the domain, is paired with exactly 1 y in the range. Okay, my little tip is basically you don't want any of the x's repeat. So basically no x's repeat. Okay. So in other words, if you're given ordered pairs, if the x's repeat, then it's not a function. Okay. If you're given a graph, we're going to use the vertical line test. Okay. And basically, you're going to do all your imaginary lines, and if it only hits 1 point per imaginary vertical line, it's okay. But if it hits more than once, and we'll talk about this in a second with some examples, then it's not a function. Okay, and I'll show you also in the mapping, if the x values repeat, then it's not a function. Or you can think of it in mappings. Here. If the x's have more than one arrow, then it's not a function. Okay. So here with ordered pairs, all we want to do is check to see if there's any x's that repeat. And if there's any repeated x's, it's not a function. So here when it says determine whether the following are functions, all we have to do is say yes or no. So I just check all the x's. So we have 5, 3, 2, 0, 1, negative 1. Nothing repeated, so yes, it's a function. So number 2, you have 2, 0, oh wait, negative 2, 0, 2, but this 2 and this 2 automatically repeat. So automatically I know it fails and it's not a function. No, it's not a function. Okay, I'm going to have you do 3 and 4 on your own. Now let's look at 5. So again, I just looked down, oh, right here, I didn't even have to say them all. Automatically, since the x's repeat, no, it's not a function. So I just looked down, well here, none of them repeat, so yes, it is a function. I'm going to have you do 7 and 8 on your own. 9 and 10, so remember with mappings, if you have more than one arrow, that means the x repeats. So we don't want more than one arrow. So here, and remember the domain is the x's, and this is the range. So we just look, there's only one arrow for each one, so yes, it is a function. But if you look at number 10, all of a sudden here, because there's 2 arrows from negative 1, that means that negative 1 repeats. And remember, domain are the x's, so this is not a function, okay? Now I'm going to have you do, oh, they don't have any mappings on your own. Okay, well, let's look at vertical line tests. So basically, if you look at the grid, notice that vertical line went through only 1 point, but then all of a sudden it went through 2 points here. So as soon as it goes through more than 1 point, it fails. So no, it's not, because that tells me the x repeats. In fact, each one of these points has the x is positive 1, the y is positive 2 here, and the y is negative 1 here, but the x's repeat. That's why it fails, because it hits the vertical line twice. You only want the vertical line to hit once. So like here, all of these vertical lines are only hitting these points once, so yes, it is a function. Okay, I'm going to have you do 13 on your own. Now look at 14. Each line represents an infinite number of points, okay? So if you look right here, automatically it hits twice. So because it hits twice, it automatically fails and it's not a vertical line test, okay? So I want you to try 15 and 16, and just so you know, 16, like these arrows just mean it's going to continue forever in the same direction. In fact, let's just go through these together. So here we know each one of these are only hitting this line once, so yes, it is. And same thing here, if I was to draw all these vertical lines, it's only hitting that curve. When I say curve, it's that line once. So yes, it is. And then over here, all these points, it's hitting once until we get here, and this is where it fails. So no, it's not a function. Okay, in fact, let's just go through these other ones real quick. So number 3, if you notice, if I look at all the x's, they're all different until I get here. So in fact, like maybe it's easier if I circle them like I've been doing. So those are the same, which means the x's repeat and it fails. It's not a vertical, or it's not a function. It would also fail the vertical line test if we graph these. So same thing, if we look at all the x's, in fact, 1, 2, 3, 4, 5, none of them repeat, so yes, it's a function, okay? So again, if we find repeating x's, it fails as a function. So over here, none of the x's repeat, so yes, it's a function. And over here, well, automatically I notice those 2 x's are 4s, so it fails, and no, it's not a function.